Today I'm going to look at testing components using a multimeter. The most useful setting on multimeters for technicians is the resistance setting in ohms. And we usually have to plug into a common and a terminal with ohms. It's often shared with the voltage as well. You can see it says 1 at the moment. That is because the resistance is higher than the meter can register. If we connect the test leads together, we get 0, no resistance. If you have a component such as a lead, that will obviously have very little resistance or no resistance. And a fuse should have virtually no resistance as well. A fuse is a piece of wire that will get hot if it has too much current. And this one is actually a blown fuse, I believe. I'll save for this purpose. So that doesn't conduct electricity, touching the wire on each end. This one I believe is also a blown fuse, but a good fuse would give us a 0 reading on the multimeter, or a very low reading. Bulbs, you can do in the same way, touch one to the casing and one to the bit at the end. This is a good bulb, so it's giving me a low resistance reading. The bulb is essentially a little coiled filament of wire, a little thin bit of wire that heats up and glows. Let's try this bulb on the casing. Well, on the end, that's a dud bulb. That one has been blown because too much voltage has been applied and too much current has passed and the wire has broken. Bulbs sometimes also blow through age, getting hot and cooling down multiple times makes the filament brittle, and if they're dropped as well, that little fine filament can break, and then the bulb no longer conducts electricity and no longer lights up. So testing components, basic components with a multimeter, a useful skill.